Hello and welcome to the video. Today we'll be looking at something called profiling in Python. Now, if you're like me, you've probably used a lot of these time statements to figure out which parts of your code are slow. While this is okay for simple scripts, it doesn't really work that well if you have a large and complex software project. So in cases where you have, multiple functions where one calls the other, this really isn't the best way to do it. So for that, we use something called a profiler. In Python, there are a number of profilers, and this is they offer a more systematic and professional way to profile your code and figure out which parts are slow and which ones are fast. So we'll be using cProfile today and see how it's implemented and how we can use it to figure out what parts of your code need to be optimized. All right, let's look at some code. So we begin with this fetch orders function that is basically a loop that runs for 1,000,000 iterations. It creates a number of orders and appends them to a list and then returns the list. After that, we have a process orders function that takes in the orders and adds up the price of each order to get a total revenue. It then also returns the total revenue. Finally, we have a generate report function that takes in the revenue and generates a report. It also sleeps for 2 seconds just to simulate some time being wasted here. The main function calls the functions in that order. So fetch orders followed by process orders and then generate report. The report is printed after generating. Now, the way we use cProfile here is to wrap the function. So we know that everything that's being called is inside main. So we wrap this main call in between this cProfiler. So we begin by creating a profiler using cProfile.profile, and then we call profiler.enable. Then we have basically the function that we wish to profile, followed by profiler.disable. So everything in between enable and disable gets profiled. After that, we generate statistics using the pstats function. We also sort it with a metric, in this case, cumulative time. There are a couple of other metrics as well that we can use. We'll look at them shortly. After this, we can either print the stats, or we can also dump them in a file, which I'm doing here, and this makes it easier to visualize later. Now, just one small thing, there are other ways to do this as well. I prefer this because it's more explicit, but there are other ways to do it. Let's run this. Okay, it's now done running, and you'll notice that we get the total number of function calls here, along with the time the whole program took to execute, followed by an ordered by statement that tells us what we ordered by. In this case, it's the cumulative time. Now, the first line, we see basically the function taking up most of the time, and that is the main function. Now, you'll notice here that the total time is 0, whereas the cumulative time is 8.973 seconds. The total time is the time that the function spends executing its own logic, and it does not include time spent making calls to other functions. This is why it's 0, because it's not really doing anything apart from calling these 3 other functions. It's only just printing, and that's taking negligible time. The cumulative time is the time spent in the function as a whole, including calls made to other functions. So as we can see here, basically in main, most of the time is spent making these 3 calls. Now, if we move down to the second line, we'll see that it's the fetch orders function. And here you'll notice that there's actually a difference in the total time and the cumulative time. The cumulative time in this case, it's a bit hard to see what function calls are being made, but if you look closely, you'll see that it's the random.randint. That's like the only functions call being made. So that's these actually are the ones taking up most of the time, 5.4 seconds, whereas the total time is 0.73. So the total time in this case would be time spent doing other stuff. So things like creating the list, appending to the list, creating the dictionary, doing the iterations, and so on. Now, this is still a bit hard to visualize this format, also because it was a bit hard to see how the random int relates to sort of this value and so on, and also because the code is sort of, if you have even more function calls in the code, it would be even harder to visualize. So to visualize this, there is a super cool application or a Python package that you can install. It's called snakeviz. You can just install using pip. I already have it installed. But basically, once you've installed it, you can write snakeviz and then just give it the name of the file that the dump that we made. All right, so you'll notice that you get this super nice, super cool visualization. It's an Icicle style, whatever that means. But so you have the main function taking most of the time, and then you can see here that The fetch orders is taking 5.49 seconds, generate report is taking 2 seconds, and the process orders is taking 1.48 seconds. So you get this super nice visualization, and you can also go, so you can go like deeper and deeper into the call stack, and this is what really, you know, makes this such an amazing tool, because you can now see that inside fetch orders, it's actually the random int function that's taking up most of the time. And so this is where you should be looking into optimizing your code, since that's, you know, the biggest chunk of it. You can also notice here that in the generate report, it's the time.sleep. It's the 2 second, you know, time.sleep that we that I wrote in the code that's taking 2 seconds. In the process orders, you'll notice here that if you just look to the left of the screen, it's the built-in start. It's the sum function that's taking up most of the time. So this is, again, super cool, super nice. You also have this table here where you can sort by all these metrics and figure out where the time is being spent. So again, in this example, you know, if this was a real life example, you would probably be looking at this block and then going down here and figuring out figuring out the length of the longest block, and then looking at where the time at how to optimize that. Thank you so much for watching. I hope you enjoyed this video and learned something new. If you did, make sure to like and subscribe, and see you in the next one.